Hello, I'm Kamal Kapadia, and I am honored and delighted to give this talk for ClimateChange.ai's summer school. So I'm going to jump right in and share my screen, and let's get started. The title of my talk is Meaningful Climate Action. What does it look like and how can you achieve it? I am co-founder and chief learning officer at Terra.do. Terra.do is a green skilling platform for the climate economy. Let me start by just telling you a little bit about myself. This is a picture of me at the start of my climate career, late 1990s. I worked for a company, Celco, and what we did was rural electrification with solar PV in India, Sri Lanka, and Vietnam. And this is just me with some colleagues and a solar panel that we had installed. We're actually on the roof of a house in South India. And the reason I start with this story is back then, even though I knew about climate change and I was concerned about climate change, we still talked about climate change as being something that was going to happen in the future. My primary interest really was rural economic development. I grew up in India. This was a big challenge, and I really wanted to work on this problem. And what was cool about this job at Celco is I found a way to work on rural economic development, this specific challenge of getting people access to to electricity when they didn't have access to the grid, while doing it in a sustainable way. So we were able to sort of do economic development in a sustainable way. And the reason I bring this up is because many of you may also have other interests, other skills. You may be working in different industries, public health, finance, business. You may be working in a data science company. You may be in school and studying a subject that isn't climate change related. And I think the invitation to all of us is how can we solve multiple problems at the same time? How can we solve business problems and solve climate? How can we solve public health challenges, solve climate? How can we deliver on economic development and solve climate? So yeah, this is kind of the invitation to all of us. And a little bit later in the talk, I'll come back to this topic. The framework I find useful when thinking about meaningful climate action is truth on the one side and courageous action on the other. But before we get into this, let's do a quick check-in. On a scale of 1 to 5, how are you feeling? And often a good way to check in on how you're feeling is to close your eyes and just see how you're feeling in your body, because we often hold stress in our body. Are you holding stress in your tummy? Is it all tight in your chest, your neck and shoulders? Is your forehead all wrinkled? Is that where you're holding your stress? Are you feeling like the kitten, very relaxed, number one? Or are you feeling more like the hamster, very anxious? On a scale of 1 to 5, how are you feeling? Just make a note on a piece of paper, note it just mentally. There's a purpose to these check-ins, and I'll talk about that a little bit later in the talk. So let's jump in now. Let's start with the truth. First part of the truth is understanding the problem. So let's just all get on the same page with regards to what we're talking about here. This is just a definition of climate change. It is a change of climate. You can think of climate as average weather over a few decades, which is attributed directly or indirectly to human activity that alters the composition of the global atmosphere, and which is in addition to natural climate variability or observed over similar time periods. So important words here, human activity, addition to natural climate variability. This definition is provided by the UNFCCC. You may ask, what is the UNFCCC? I'm so glad you asked. Let's talk about two big UN agencies that come up a lot in climate conversations, climate research, etc. The IPCC and the UNFCCC. The IPCC is the Intergovernmental Panel on Climate Change. It produces the kind of authoritative assessments on the state of knowledge on climate change. They don't employ scientists. What they do is they convene groups of experts to produce these assessment reports, which is kind of they update our state of knowledge, and they synthesize it. They provide summaries for policymakers, etc. The most recent set of reports they produced are the 6th assessment reports, and you can just go to their website. So again, this is a UN agency that does science. The UNFCCC is the process of negotiations for limiting dangerous climate change. So you may have heard of the COPs, Conference of Parties. These are the meetings that happen every year where all these government representatives get together to hash out agreements on limiting climate change. That whole process is managed by the UNFCCC. So remember, IPCC science, UNFCCC is the political negotiations process. So let's just remind ourselves of why we're here and what we're trying to deal with. Climate change is real, and we are the cause. The primary driver of climate change is increasing levels of greenhouse gases in the atmosphere. Greenhouse gases are gases that trap heat close to the surface of the Earth. There are multiple greenhouse gases of concern, the primary one being carbon dioxide and, to a large extent, methane. Here's a graph that shows 3 different greenhouse gases and the concentrations in the atmosphere. This Dr. Zach Labe produces great graphics. He's a climate scientist, and he produces great, amazing graphics on all kinds of climate indicators. You can check out his work on X or on his own website. And this graph just shows that these concentrations of heat-trapping gases keep increasing. Of course, those graphs were over a shorter time period. This graph, produced by NOAA, the National Oceanic and Atmospheric Administration of the US, which is a federal research agency, goes back 800,000 years. Thanks to ice core data now, we can estimate CO2 levels over 800,000 years. So on the y-axis is just concentrations of carbon dioxide in the atmosphere, x-axis is time. And you can see that while CO2 levels have been varying over time, we are now in uncharted territory. So this is basically since the Industrial Revolution. We have dramatically increased the concentration of CO2 in the atmosphere. This is last year's number, 419. We're actually closer to 425 ppm right now. And of course, we are the drivers of these increasing greenhouse gas emissions. We emit greenhouse gases by burning fossil fuels, coal, gas, and oil for all kinds of needs, specifically energy needs. Other driver of increasing concentrations of greenhouse gases are agriculture, deforestation, also to some extent waste and industry. This graph just captures the fact that this graph just shows all the different sectors that are contributing to this problem. One cool, interesting thing is we have slightly changed the trajectory here, so you can see it's just beginning to shift a little bit, but still it's extremely high overall. And of course, all of this, when you increase the concentration of heat-trapping gases in the atmosphere, you are going to increase global average temperatures. So that's really the primary driver of climate change. If you look years before present, this is another interesting study that goes back 25,000 years, and they estimate the change in global mean surface temperature. And you can see it has varied a lot, but of course, once again, we're in some pretty crazy territory here. This is again just since in the modern times, since the Industrial Revolution, when we first started using fossil fuels at scale, and we have really we're running a really crazy experiment on the planet right now. And this is just a close-up of where we're at. This is a shorter timescale showing the temperature change. You might be familiar, you might have seen these stripes elsewhere. You see them on scarves, on mugs everywhere. They were first created by this scientist, Ed Hawkins in the UK. And they provide a very powerful visual representation of the changes we are seeing. This graph just shows global temperature change relative to average for 61 to 2010. And the last 50 years, especially, not only are we warming this planet more and more, the rate of warming is accelerating each year as well. So climate change is real. We are the cause, and it is here and now. We are already experiencing the impacts. This is the BBC just put out this article a couple of weeks ago looking at record-breaking ocean temperatures. So scientists, they kind of track 55 climate observations around global observations. Sea surface temperatures is one of them. On the x-axis is just months of the year. On the y-axis is temperatures in degrees Celsius. Each one of these lines is just sea surface temperature over that year. And you can see what happened in 2023 and then what's going on right now in 2024. Of course, it's important to call out that we are currently experiencing an El Nino event. El Nino is a natural process that occurs periodically and also contributes to warming, but it does not explain this huge margin we're seeing. It does not fully explain these very, very high temperatures. And in fact, scientists are very worried about this. And this is primarily being driven by climate change. Of course, it's hard for humans to make sense of these global averages. What we really care about is what we actually experience in our day-to-day lives. So we care about extreme weather events and things like flooding that are driven by sea level rise. This is how we experience climate change. We experience them locally in our communities. This article is just from a few days ago from The Guardian, and it's talking about the heat wave that is currently unraveling across North India. Delhi experienced temperatures of 45 C. Actually, I've been seeing reports of even 50 C. People are dying from this heat wave. And the question that people may have is, how do we know this is caused by climate change? Or how do we know to what extent this has been worsened by climate change? The BBC article says that events like these extreme temperature events in South Asia are 45 times more likely now because of climate change, 45 times more likely because of climate change. And you may wonder, well, how do we know this? How can we make this claim? And this is thanks to a new, fast evolving branch of science, of climate science, called extreme event attribution, where scientists are beginning to understand how climate change is changing both the likelihood and the intensity of extreme weather events. So we're beginning to estimate how climate change is changing the likelihood and the intensity of a given weather event. So what they do in this kind of science is that they run large models and they run them with climate change and without to estimate the likelihood of any given weather event in a particular place. So they run it with what they call anthropogenic forcing, and then they run the same model with a cooler planet, like 1.3 degrees cooler, and look at what is the difference in the likelihood of any given particular event. And through that kind of research, they can say things like climate change more than doubled the likelihood of extreme fire conditions last year in Eastern Canada. You may remember that Canada had a really bad fire year last year. And that's the kind of extreme event attribution is the research that allows us to make such claims. This kind of research may be of specific interest to you all if you're data scientists. And also it's very, very important research because it's the foundation of, it's being used in litigation, climate litigation cases. It's being used to calculate risk, for, financial institutions, for example, they need to figure out climate risk. All kinds of businesses, governments, etc., insurance companies need to figure out risk. And this kind of science is very helpful in that work. Of course, all of this impacts humans. I talked about the heat waves in North India. People are dying in that heat wave, but death is not the only way in which this is going to manifest. And one story that I feel is often understudied or undercovered is how this is going to drive migration, how climate change is going to drive migration. I want to call your attention to this great set of stories that was co-produced by ProPublica and the New York Times Magazine. This is a few years old now, but it's really worth checking out. They look at how climate change is driving migration, not only globally, but also in the US domestically. And they talk about how it's kind of the thing that really pushes people over the edge. So we know that people pick up and move for all kinds of reasons. They pick up and move because of civil wars, because of droughts, poverty, violence, etc. But without climate change, they may, for example, this family might have experienced drought maybe once every 20 or 30 years. Now they're experiencing back-to-back drought over multiple years. And when people cannot grow their food, when they cannot survive, they're going to pick up and move. And in fact, what this article talks about is right now, only 1% of the world's land mass is an unlivable hot zone. And by 2070, up to 19% could be an unlivable hot zone. So this is something to pay attention to. It's happening all over the world already. So climate change is real. We are the cause. It's here and now. And all the scientists are telling us that we should not exceed 1.5 C of average global warming. So this is warming compared to pre-industrial temperatures. And why do they say this? Now, it's important to know that 1.5 C is not some absolute line that we should not cross, but it is a point on a continuum at which we begin to cross into multiple danger zones. So every 10th of a degree matters, okay? Every fraction of a degree matters. As much as we can stop warming, we should. But 1.5C is also enshrined in the Paris Agreement, which is the big global agreement that all countries kind of signed together. Most countries in the world signed in 2015. And in that agreement, they agreed to try to limit warming to below 1.5C. What this graph here captures, it's from the IPCC special report on 1.5C, and all it's really showing is how all the risks that we care about, all the impacts we care about, just worsen as we increase global average temperatures. So if you just look down here at the bottom, this looks at impacts and risks for selected natural, managed, and human systems. The first one is warm water corals, and you can see even at the current temperatures that we're already experiencing, corals are in grave danger, and we know from observations that they are already dying back. Another reason to be really concerned about crossing 1.5C is due to things called global tipping points. You can think of tipping points as a critical threshold that, when crossed, leads to large, accelerating, and often irreversible changes in the climate. Irreversible changes in the climate. There's this great new report on global tipping points that's been produced by the University of Exeter, Professor Tim Lenton and a bunch of researchers. It's great graphics. It's a great review of this whole topic. I recommend checking it out. You can just Google it. Another great resource on this is by Carbon Brief. Carbon Brief has this lovely visual and great resource on these 9 tipping points. This is a little bit dated, but still worth looking at because it kind of explains how all these tipping points work. So Greenland ice sheet disintegration, permafrost loss, Amazon forest dieback. So let's take a minute to just unpack this one. Because of deforestation and hotter and drier conditions, we're seeing a dieback of the rainforest, and it could be that it reaches a point where it just shifts into savanna. And in fact, this itself causes a sort of a feedback cycle. So right now, the Amazon, well, we think the Amazon is a net carbon sink still. There's some research that suggests it's already turned into a net carbon source, but it has historically always been a massive sink because trees remove carbon dioxide from the atmosphere. They need it for photosynthesis. But as the forest dies back and there's more forest fires and we continue to deforest, the Amazon could actually become a net carbon source. And again, there's some research that suggests this may have already happened. So this is basically a tipping point. And you can read about other tipping points in this resource. So are we on track for keeping warming within 1.5C? And the answer, sadly, is no, we are not. We are not remotely on track. Just 2 things to share about this. First, on this slide, this graphic is produced by Climate Action Tracker. Climate Action Tracker is a great organization. And what they do is they look at all the policies and actions that countries and governments have enacted, and they translate those into emission scenarios and expected temperature bands that we might see. So they're kind of assessing to what extent every country is or isn't on track for 1.5C. And it turns out, by the way, no country is on track for 1.5C. Not a single country is on track. But let's unpack this graph for a moment. On the x-axis is years. On the y-axis is global greenhouse gas emissions per year. So carbon dioxide equivalent, CO2e, is just one way of combining all the different greenhouse gases into one metric. The black line here shows you historical emissions every year. This little dip is COVID, and of course, we went back up right after that. Now, I want to draw your attention to just 3 things in this graph. First of all, look at this big blue wedge. Okay, this wedge shows us where we are currently headed. So if you add up all the policies and actions of all the countries in the world, we are headed towards 2.5 to 2.9C of warming. So you can see nowhere near on track to stay within 1.5C. The second thing I want to draw your attention to is this blue line. This blue line says pledges and targets. And the difference between pledges and targets versus policies and actions is that many countries and many country governments have made some promises. They've said, oh, we're going to reduce emissions by this much, or maybe have a temperature goal. But they do not translate these into policies that would actually result in us achieving or that country achieving the goal. So there is a gap between what is being pledged on paper and what policies are actually being enacted. The policies are always weaker than what the pledges claim they might achieve. So if we were actually on track with our pledges, we would be in a little bit better place, 2.1C. Of course, the line we need to be on is this green line. Okay, we need to be rapidly reducing our emissions, getting to zero, and then going net negative in order to be 1.5C consistent now. And this is the reason we have to go negative is because we've delayed action for so long. It seems almost guaranteed that we will overshoot 1.5C, and then if we're lucky, we'll be able to bring it back down with a lot of carbon removal. I'll talk about that in a minute. But the sort of rule of thumb is that we need to cut in half all our emissions by 2030. Yeah, that's in 6 years, and then get to zero or net zero by 2050. And I'll talk about what that means in a minute. Okay, so that's kind of just where we're headed. Where are we right now relative to 1.5C? This graph was just shared today. In fact, I'm recording this talk on June 1st by Dr. Zeke Hausfather, who is a leading climate scientist. He's an amazing science communicator. He's on X. And he also publishes a newsletter. So you can follow him on X. I really recommend it if you want to stay up to date on the science. What he shows in this graph, again, X-axis is years, Y-axis is a temperature anomaly. So again, this is temperature increase relative to pre-industrial. And you can see that it's really been accelerating recently. And right now we are 1.6, the 12-month running mean, mean of the monthly global temperature anomaly is at 1.63. So we are currently 1.63 C above pre-industrial. Now, this doesn't mean we have crossed the proverbial 1.5C. Okay, and this is because this is just a 12-month mean, and the 1.5C would be a running average over 2 decades. Of course, the sad thing there is that we may not know that we've crossed 1.5C till 10 years later, but this is already sort of really worrying trend, you can see, and scientists are extremely worried about this. So how are you feeling? Time for another check-in. Again, just make a mental note, compare it to the first time we did this. Are you very relaxed? Are you very anxious? Look at the kitten, look at the hamster, decide where you're at, and make a note of it. Let's move on. All right. The other part of the truth, of course, is the solutions. So now let's talk about solutions. I've kind of lumped solutions into 3 categories here. There's mitigation, there's removal, and there's adaptation. There's also a 4th one called geoengineering. We're definitely not going to have time to get into it in this talk. It's kind of still really highly experimental. And yeah, so we're not going to cover it in this talk. But let's talk first about mitigation. Mitigation is just reducing our emissions and getting down to zero or net zero. I'll talk about that too in a minute. So we should rapidly reduce our emissions of greenhouse gases. This means we need to just stop burning fossil fuels, stop deforesting, change our agricultural practices, etc. This image here is a wind turbine because it's a way to generate energy with renewable resources as opposed to using fossil fuels. Carbon dioxide removal is actually removing carbon dioxide from the atmosphere. There's a related thing called carbon capture that's kind of just capturing carbon dioxide straight out of a smokestack. I've kind of just lumped them both into this category for now, removal. There's natural and technological ways to remove carbon dioxide from the atmosphere. This just shows some trees because trees are great at sucking carbon dioxide out of the atmosphere because they need it for photosynthesis. And of course, then there's adaptation. Adaptation is learning to live with climate change. This is just a picture of a poor community. The houses are on stilts because it's not easy, but it's one way, cheap way to deal with flooding. So that's kind of what this shows. Now, in this talk, I'm only going to focus on mitigation for the key reason that we cannot substitute mitigation with anything else. So we need removal, we need adaptation. Unfortunately, because we're already into climate change, we need both these things, but they are additional to mitigation. Okay, if we do not reduce our emissions rapidly and get to zero or net zero emissions, we will not be stopping climate change, and these things will not save us. They are not substitutes. They are not substitutes. They are additional to mitigation. This is very, very important. If you just take a few things away from this lecture, this is very, very important thing that I would like for you to take away, that mitigation is the most important thing, and none of these other things will save us if we don't rapidly reduce our emissions. And the key reason for this is carbon dioxide is a long-lived gas. So when we put a pulse of CO2 out in the atmosphere, or a molecule of CO2 up in the atmosphere, 55% of it approximately is removed by natural processes. So trees absorb carbon dioxide, oceans dissolve carbon dioxide, but the remaining 45% stays up there for a very long time, hundreds, thousands of years. Some amount of CO2 is removed by geological weathering, so rock weathering, but that's a very, very slow process. So basically what this means is once you put any CO2 up in the atmosphere, it's going to start trapping heat, and it's going to stay up there for a very long time trapping heat. So there is no substitute for rapid emissions reductions, and now is vastly preferable to later. We will only stop global warming. We will only stop increasing the temperature of the planet when we get to zero or net zero emissions globally. And net zero means eliminate almost all emissions and just remove the rest, suck the rest out of the atmosphere. So even if we reduce our annual rate of emissions, okay, every year we add a little bit less to the atmosphere, we will still be warming the planet, because again, remember, every molecule of CO2 contributes to warming. So we will continue to warm the planet just at a slower rate. And the only small piece of good news is when we completely eliminate emissions, go to zero or net zero, that global warming will stop. Increase in temperature will stop about 10 years after we stop emitting. So it's not a sort of, we can stabilize temperatures, but remember, we will only stabilize at the temperature that we have reached at that point. So very, very important, another important takeaway, we have to get to zero or net zero emissions. That means we have to stop burning all fossil fuels. Like, we have to stop, okay? This is very, very, very important. So when we talk about solutions, just a good reminder of what are the sources of emissions, which will tell you like where we should be dedicating our relative effort. Energy is the biggest source, buildings, transport, industry, agriculture, forestry, and land use is another huge source, and then industry and waste. This is just direct use of, this is direct emissions caused by industry as opposed to energy in industry. So for example, when we make cement, we kind of strip out the CO2 from calcium carbonate to make like lime that is more reactive, and that CO2 just goes straight up into the atmosphere. So these are direct industry emissions as opposed to emissions from energy use in industry that's represented here. The good news is we have all the solutions. I recommend checking out this resource called Project Drawdown. We have all the solutions now. Most are economically viable. Solar energy, for example, is the cheapest form of electricity everywhere in the world today. It is cheaper than coal. This is an amazing achievement, because when I started in solar in the 1990s, it was incredibly expensive. And we could only dream of achieving the kinds of prices we're seeing today. What's cool about this resource is you can click on any of these sectors and then go deeper into all of the solutions within it. You can look at the economics, you can look at their climate impact. The reason I put an asterisk on the all is because there are still a few sectors that are called hard to abate sectors, like aviation, certain industrial processes, where we still need some innovation, we need research. But for the vast majority of emissions, we have the solutions. We just need to deploy, okay? We have the solutions. Now, Project Drawdown organizes the solutions into sectors, and this is a traditional way of thinking about it. So in the energy sector, for example, we need to go 100% clean we need to get all our electricity from renewables. And the other side of the solution is, as we clean up the grid, we need to bring all of our energy uses that are currently not based on electricity, we need to electrify them. So you might have heard of this solution called Electrify Everything. So for example, we use natural gas to heat our buildings. We need to switch that heating source to electric with heat pumps. We need to switch industries, all kind of industry energy uses to electricity as far as possible. That's why there's an asterisk. There might be a few exceptions. And then transport, you've probably heard of electrifying transport. And these two things are very complementary. As we clean up the grid, as we run our grid on clean sources of electricity like solar, wind, storage, hydrogen, and we electrify these other sectors, these two things are quite complementary and kind of support each other in different ways. Of course, we need to transform the food system. The biggest problem here is our beef consumption. Cattle emit methane directly, but also the land use impacts, as in the amount of land we need to grow the food to feed the cattle is huge and keeps increasing because beef consumption globally is increasing, and that drives a lot of deforestation. Like agriculture is the primary driver of deforestation. Clearing land for agriculture is the primary driver of deforestation. So obviously also we need to protect nature, protect our forests, and then we need to clean up industry directly. But the other important framework, sort of mental model for thinking about these solutions is levers for change. And this is often where maybe your skills are. Like you might be an engineer, your skills might be in communications, education, economics, finance, you name it, corporate strategies. And all of these are cross-cutting levers for change. And they're all equally important. This is very, very important. We often think of climate change as just a technological challenge, a technological problem, and it is not, okay? All these things are very, very important, and they're all equally important. And so if your skill is in one of these areas, that's great. Lead with that skill because we need it. We need it, and we need all of these different skills. Now, there's one very important thing I need to call out is that justice cuts across all of this. We know that climate change itself is impacting different people differently, different parts of the world differently. But what people don't pay enough attention to is how climate solutions themselves are affecting people. So we have, for example, new supply chains for all the new minerals we need to build batteries and all of the new technologies that we need. So what's going on in these mining communities? Like, are people being treated fairly? Are they being paid fairly? There's also other justice implications for these solutions, like a lot of conservation efforts around forests are kind of involving indigenous communities. Who gets to benefit from all these solutions? Who gets to benefit? Who's getting left behind? These are really important questions that we need to pay attention to. At Terra, we have a course called Climate Change Learning for Action, which is our climate bootcamp for professionals. And I run a climate justice workshop in that bootcamp. And the one thing I really try to convince people of in that workshop is that if we do not center justice, we will not be successful in solving climate change. Yeah, if we do not center justice, we will not solve this problem. I realize that's a very provocative thing to say. If it makes you wonder if it's right, I invite you to come to our course and to engage in a discussion around this. I mentioned right at the start when I talked about myself doing the solar work that, it was great to be able to solve it was great to be able to work on development and also do it in a sustainable way. This framework of multi-solving is very useful, and many of you might find it useful as well. I grew up in India, and in India, you can't really talk about climate change without talking about development. There are so many development needs. So to the extent that we can solve multiple problems at the same time as solving climate change, we should. Climate action should be about good jobs. Climate action should be about meeting basic needs. Climate action should be about new models of development. We should be solving these problems in an integrated way. You can look this up, multi-solving, and again, just calling out the person who first invented this term, Elizabeth Savin. She's got some great resources on this. So we've covered the truth part of the story, both the problem and the solutions. Now it's time to talk about courageous action. I've borrowed this concept of courageous action from the All We Can Save movement. It's both a movement and a book. It's also a set of principles for new kinds of leadership that we need as we deepen into this era of climate change. They separate courage and action, but I find it useful to combine them into one idea. So one of the sort of challenges that people face when they are thinking about working on climate change is that the problem feels so big, so overwhelming, so complex. It feels like it's kind of a global systems problem that you as an individual feel disheartened. You don't know how to engage effectively, and you don't know how you as one individual can shape this whole huge, big systemic mess that we're in. So let's unpack this a little bit, because I think it's very important that we understand how we as individuals can shape systems. The most important piece of research I read on this topic was published recently in Nature Climate Change. And it's this article called Globally Representative Evidence on the Actual and Perceived Support for Climate Action. And in this study, the researchers interviewed 125,000 people, yes, 125,000 across 130 countries, to understand individuals' motivations to act on climate change. And what they found blew my mind. They found that the vast majority of people, no matter where they are in the world, are ready to take action. They're even ready to donate 1% of their personal income, irrespective of whether they are rich or poor. But they don't act. They don't act because they systematically underestimate the willingness of their fellow citizens to act. So let's take a minute to process this. Everybody's ready to act on climate change, but they don't because they feel alone. They feel like their colleagues, their family, their friends, their bosses are not willing to take action, so they don't take action. This is one of the reasons why at Terra, we run a lot of courses, but we see that skills acquisition, knowledge acquisition is only one part of what learning needs to be about. Another very, very important part for getting people to take action is having a supportive community. Okay, so that you don't feel alone, that you are surrounded by people who are also taking action, and you are much, much, much more likely to take action yourself. So at Terra, we have a very, very supportive community. ClimateChange.ai itself is a community. This is why all of us who are working on this emphasize community so much. And of course, the third thing that we emphasize is emotional resilience. Because as you learn more about the science and as you get deeper into this work, you'll find that it is very hard and you are likely to be anxious. The reason we have this problem is because the whole system is stacked against us being sustainable. The whole system is pulling us into an unsustainable pathway. And so the work is hard. And so we really, really need emotional resilience in order to sustain doing this work. And this is why I did those little check-ins, just that sort of moment of presence where you kind of check into your body. This is just a tiny little taster of ways in which you can practice self-care. Okay, self-care, care of each other. These are all really, really important parts of how we will turn up to care for the planet. But I will say that learning, knowledge acquisition, community, and emotional resilience, even this is not enough. Even these are not enough. There's one more thing that we all need in order to effectively shape the system. So let me come back to this graph to tell you what I mean. Now, the one thing I didn't show you the last time I showed you this graph is that about 15 years ago, all of us thought we were actually on this trajectory. So if you go back and look at the old IPCC reports, we thought we were headed to something like 4C, 4 to 5C, runaway climate change. And you can see that we have actually bent the curve. We have bent the curve in the last 15, 20 years. And what has bent this curve? What has bent this curve is hundreds, thousands, maybe millions of individuals pushing for change, no matter where they were. So if you worked in government, if you worked in companies, if you were in university and you were a student, if you were in communities, people took courageous action. And the courage part of this is really what we need. We need courage because the system is stacked against you and this work is going to be hard. You have to push, you have to convince, you have to argue, you have to fight for this change. And this whole system, we shifted the system from this red line to this blue wedge because millions of people took courageous action. And of course, what we need from you all is more courageous action. So this really is a key part of how you can see from this graph, individuals, millions of individuals have shifted, already shifted the trajectory. And you all are going to continue this work because we need to shift even more. So, but let's just focus on the individual action part of it. So usually when people ask this question, how can I as an individual affect climate? The usual answers take three forms: that you can change your behavior as a consumer, you can change your investment behavior, and you can sort of take different actions as a citizen. So let's break this down a little bit. Consumer behavior is your purchasing habits. So ideally just buy less stuff. But also if you have money, you can buy solar panels, put them on your roof, change to an electric car. Investment behavior is if you have money to invest, just make sure it's not going into driving into activities and companies that are worsening the problem. Make sure your investments aren't flowing into fossil fuel companies, etc. And your behavior as a citizen, if you live in a country where government is responsive to citizen pressure, you can influence government in all kinds of ways. You can join groups that are trying to get climate first candidates elected. Like, for example, you can join groups that are really pushing the government to enact more ambitious policies. I used to live in Hawaii. I don't live there anymore, but I used to live in Hawaii, and I worked before this job, I worked for an organization called Blue Planet Foundation. And we were a clean energy advocacy organization. We were a very small group, just like 10 people. And what we did is every year, we tried to get climate legislation passed at the state level. And in fact, this organization was the one that pushed the state to adopt the US's first ever 100% RPS. So Hawaii was the first state in the country to pass a law that required 100% of its electricity come from renewable sources by 2045. California passed a similar law, but that was 3 years later. And this organization, Blue Planet Foundation, is the one that pushed the government to adopt this law. So even a small group of people can have massive impact on government in countries where this is possible. But I think one thing that's missing from here is actually how you can influence the climate through your job and your career. In fact, I have come to believe that this is the most powerful lever you have. Think of the amount of time and effort and talent and skill you are going to put into your job and your career. And how amazing would it be if you could dedicate your work to solving climate change? And in fact, there's no better time than now to do this work, because we are seeing that climate action is bottlenecked on talent. LinkedIn every year does this green skills report, and they found last year that the growth in demand for green skills is outpacing the increase in supply. BCG did a similar study, and they found that there's a massive skills gap in the green economy. The International Labour Organization said that we will not achieve our policy goals if we don't sort of build these skills and get people deployed into this work. The International Energy Agency has said that in clean energy, skilled labor shortages are already plaguing the sector. So it's great that you've turned up in this course, you're building the skills. This is what we like to do at Terra as well, help you build the skills that you need to do this work. And really, there is a huge need right now for green talent to be doing this work. So how exactly can you use your skills to address climate change? This course is helping you do that, but this is also what we focus on at Terra.do. So I just want to call your attention to this one particular course we run. It's a climate bootcamp for professionals, and it helps you identify specifically how to apply your skills to this challenge. We've graduated 3,000 people, almost 3,000 people now from this program. The majority of professionals are actually working on climate after taking this course. And yeah, it's I recommend that you can just come to Terra.do and check it out. And yeah, any questions you have, you can also follow up later with some questions about it if you need answers. I just want to highlight a couple of stories here of people who've taken this course who have sort of data adjacent backgrounds and experiences. This is a story of Pia Faustino. Pia is an early graduate of she's from one of our early cohorts. And just before she joined the program, she still works in the same company, Thinking Machines Data Science. And right before she joined Climate Change Learning for Action, they had created this new position there, Director for Social Impact and Sustainability. And she came from a business. She had a business kind of sales job position before this. She switched into this, and she found it really hard to figure out how to pivot the whole company to do more of this work. So I remember having a conversation with her, and she told me how she would turn up in kind of sales pitches with, say, energy companies and just not have the context, not have the vocabulary to understand kind of the problems and how data science solutions could help. After taking this course, she felt really, really empowered to help the company make this switch. And in fact, I find it, I've been following her on LinkedIn, and I notice how so much of their work now is focused on climate. They do tons of clean energy projects. And this little post of hers from 5 months ago talks about this interesting new project they have to map out the climate data ecosystem of the Philippines. And I should have said she's actually based in the Philippines, the company's in the Philippines. Another story, this is broadly from tech. Blair, managing director of partner analytics, business development at Meta. He took the course. He went back and convinced his bosses to make him global head of net zero and sustainability. And yeah, he made the transition just with this course. So, and of course, now he's also having massive impact leveraging AI. This is just a post about partnering with WRI to do a big mapping project on nature-based carbon removal projects. So again, if you're interested and you want to apply, this QR code has a 10% discount embedded in it. I've also included the discount code below. We also give scholarships for folks who are interested. So if you have a financial need, there's a place in the form to indicate your scholarship need. And we also offer all kinds of other courses. We have specific courses on data science as well, for software engineers as well. Feel free to check them out if they are of interest. So last couple of things I want to say is, as you do this work, you'll discover it is so much more than a job, okay? It is deeply satisfying work. You end up with a group of peers, colleagues who are value aligned. Every day, your work is in alignment with your own personal values and what you want to see in this world. It is very deeply satisfying work. So again, the last little check-in. Let's quickly check in and see how we're all doing. Are you very relaxed? Are you very anxious? I hope you're not as anxious now as you were after all the science stuff that we covered. I'm going to leave you with one last prompt. This is actually a version of our very first assignment in Climate Change Learning for Action, our course at Terra.do. And this is just to like prompt you to think about how you are going to help solve this problem. So the year is 2045 and the world has successfully solved climate change. And you are one of the many heroes of this transition. And your story was inspiring to millions. So think about one courageous act that will be part of your story, because guess what? You've been invited now to Terra.do to share your story. And Terra.do at this point is also a huge platform with millions of people on it. So think about what is one courageous act. Remember, a courageous act involves stepping outside of your comfort zone and doing something that's different, that's challenging. Use your imagination. Think of courageous people you admire and their stories. So I'll leave you with that. Thank you so much, and I wish you all the best.